Hello everyone, welcome to this video on PDG and how to use tops in Houdini. So you might have heard of PDG and tops and you have seen videos online demonstrating its fantastic uses. But there's a lot of challenges in actually adopting it. And as you can see from those frustrated beginners, there is a lot of challenges trying to understand even the basic tutorials. And that is what I'm going to try to do in this video. Now this video is going to be quite challenging because I want to share quite a few information from quite a few different sources, and I will add my own comments. So I will try to do it in a structured way, but just be aware that take it slowly and we will cover a lot of different stuff. PDG, if you look behind the terminology, which doesn't really need to make any sense to you, it's essentially just a batch processing framework. For any individual like me, like people who are learning the cloud, computer farm, multiple cores, doesn't really matter at all. The only thing that matters is it allows you to build your own batch program. So that's the first thing to figure out. So in order to understand it, because it's a batch processing framework, you need to understand how actual command line processing works. And that, I think, can go a very long way. So the first thing I'm going to cover is to show you how actual command line works. I'm not going to go to all the basic details, but I'm going to show you how to manually process something that is going to be shown in the official tutorial. So in this case, we have this folder with your Houdini installation. It has those two archives. I'm just going to make a copy of those archives into my desktop, create a manual folder, and paste those archives here. That is our very original input. In order to do the processing, we are going to use command lines. So our goal is very simple in this case. We are going to unzip those archives, and they contain a bunch of JPEG images inside. We are going to convert them into PNG, and then we are going to compress the PNG files into a new archive. So basically that's how it works. Notice here, if we open in the terminal, and here I'm going just to use the PowerShell because it has some very handy commands, but if you use bash or cmd, it works kind of similarly. I'm going to extract an archive. So the first command I'm going to use is called expand archive. And the first parameter it takes is the archive name. The second parameter is where do you want to expand it. I'm just going to expand it in this folder. Because the archive itself already contains a subfolder, so the subfolder is extracted, and we have a bunch of files inside. That is the first command we use. The second command we use is to use ImageMagick to convert the JPEG to the corresponding PNG. Let me open another terminal here. The way you use ImageMagick is very simple. Do magic, put in the first file name, put in the last parameter is the output file name, and then run it and see it converts it. Now notice what happens if I do more than one. frame2 and frame1.png. Okay, so now to intentionally confuse you, I'm saying frame1.png, which make it look like it's going to convert this one to this one, and it's not going to know what to do with this one. So if we just run it, you can see it actually runs fine, and it actually outputs two images. And the two images all share the same prefix with 0 and 1 as its suffix. So instead, if we make it clear, we can see that this is a prefix, right? And let me just delete those two. And then run it. You can see ImageMagick is going to automatically treat the file name as prefix and put those as the numbers as suffix. So that is how ImageMagick works. Now, after you have converted everything, you can again use another command called compress archive. And the first parameter is the folder that contains all the files you want to compress. The second argument is the output archive. Here I'm just going to do this. So it will output this one, which contains the original stuff. All right, so that is how you do everything on the command line manually. Now we can talk about the Houdini way, which is to use top. As I mentioned, the PDG context or top is essentially just a way to run those commands, but instead of doing it manually, it's allowing you to construct your workflow in a load-based format. So in this case, let's say we want to do conversion, right? Convert images. We can use a load called, let me create a top network. We can use a load called ImageMagick. Now this load allows you to do a whole bunch of things, including, if you scroll down, we are going to talk more about other options later. But if you scroll down, you can see a few operands we have. We can do montage, we can do convert, we can do composite, compare, import, conjure, right? So the convert is one we use to convert from one thing to another thing. So the behind the scene, this is just calling the ImageMagick that I have installed. And in order for Houdini to know where that thing is, it's using a convention. You see here, it's trying to look for the ImageMagick binary. So you need to make sure your installation is available in your path. So you see, I have installed actually 2 different versions, right? You need to make sure it's available in your environment path, which I will not talk about how to configure in this video, but it should be fairly straightforward if you have experience with command line. Then, because you see, it's actually by default looking for ImageMagick, not Magick. You need to tell it, what is my Magick name? In our case, it is called Magick. That way, Houdini knows where to find this underlying program, right? The same thing works with ffmpeg. And you see, it allows you to specify, either Houdini ffmpeg or system path, or use a different one, right? Whatever you use, right? So that is how it works by interfacing with other existing system programs. The next thing we want to talk about is to really understand the concept of top loads. But before we do that, I think it's very informative or illustrational whenever we go to any new context to take a good, careful, slow look at all the loads it offers. I think this gives you a very good overall understanding of what it can do. So in this case, I'm going to walk you through it. Now notice when we look at those things, we don't need to fully understand what each load does, but just have some impression of the idea of the category. So here we see we have a bunch of loads dealing with attributes. And then we have a bunch of loads dealing with data. And you see we can deal with CSV, which is very interesting, and SQL, right? And then we have dependencies. Here we can see a bunch of things that partition. You don't know exactly what that means yet, but okay, we can possibly partition stuff. And then we have files, even download a file, right? And also those are apparently doing things on the local file system, right? Rename, move, copy. And we can deal with geometries, we can deal with images, and you notice that it's mostly done through external programs, ffmpeg and ImageMagick, right? And those other stuff. Labs provide some interesting stuff, including machine learning, computer version, right? Which looks very exciting. And then we have a bunch of other stuff, and we have dedicated tools for machine learning. And managers are just traditional stuff. You can include other contexts inside this context. Loadify, partitioner, and you will notice that this one is just, most of it is repetition from the previous one. We can do Python, we can render stuff, you can schedule, no idea what those means, but okay. And then we can somehow create something called service block, looks like it's interfacing with external program. And then service, okay, those are probably related to how distributed computing works. Simulation, top, USD stuff, utility. Look like we can, the usual load, null, output, merge, shell, call external shell, supposedly. Work, hide, and expand, looks interesting. And then even do version control, right? So just after maybe 1 minute or two, you have a better understanding of the capability of the entire top network. And I think that's something worth doing. Let's look at how it actually works. And this one is the challenging part of this tutorial, and I wish I can explain things in a clear fashion. There are first of all, two distinct kind of entities you are dealing with inside a top context. The first one is the top load itself. So a file pattern, for instance, is a load that allows you to fetch all the files using a pattern. It returns a bunch of file names and file paths. So here, in this case, let me just go to this folder, right? And then I'm going to put it here. And then if we just run it, you can right-click, do dirty and cook this load, or just do Shift-V to run this one. I'm going to just run this guy, and also make sure we do a wildcard. Right, we're filtering everything inside that is zip, and then just run this guy. The file pattern failed to cook, probably because of the path issue. Right, hopefully it works, and then run this one. Oh, still doesn't work. Oh my god, that is going to make it complicated. Desktop test, top example, accept. Okay, let me just do this one. Okay, so maybe it doesn't accept the space. And then do this one. What? Oh, okay, I think I know why. I need to drop in a local scheduler. I think I deleted this one just now. Yeah. Okay, good. So that is this one, just put it somewhere. It's configuring your local scheduler. And then here we have the file pattern. So we were talking about the two different kind of objects we're dealing with. The first one is the load itself, a top load. Second one is a work item object. So each work item is actually a distinct entity. And I find it very useful to be very careful and understand which entity we are dealing with. When we are connecting those lines, it's communicating between those loads, right? But when we are inside each load, what it does is actually dealing with the items. And each one of it can contain attributes. If we look at this one, those are the attributes for the file pattern load. It will show you an aggregate of all the output files it found. And then if you middle mouse click on the work item, you can see it has its own load properties here. It shows you cook time, cook info, and all the attributes that is available on this work item itself. When we work in the top context, it's very important to be aware of such things. And I'm going to explain more about this later. But first thing, I want to show you a bunch of those kind of, syntax stuff. Here for file paths, we apparently can use a wildcard, but we can also do some other stuff like the usual, like heap, like global variable, and you can do something like, I think it's like this OS, right? And then you can do stuff like not specifically in this one, but you can, for instance, if we do ImageMagick, you can put in your paths in this weird fashion. You see, we have these variables, and then you have this syntax to do this kind of stuff. I'm pretty sure Houdini has a name for this, but those are apparently two different kinds of variables, right? And then you can even do something like this, input file paths, right? So we have immediately 3 different ways to include variables effectively in a string. And where do we find reference for those things, right? This one, I'm not sure where you can find a reference, but this one, you can find a reference here. If you go to using attributes, so here if you go to using attributes, you can find the section on all the built-in attributes. You can see that is the built-in attribute. So you reference them in this fashion, okay? The other syntax, which is the curly bracket, you can find information about it on the specific load. So ImageMagick is a top load. It has a section on top attributes. Those are the ones you can use when referring to the attributes like defined or created by the load when the work item is going through it, right? So that explains the sources of those 3 things. And then let's talk about one other thing. It's just out of curiosity or just for the purpose of being comprehensive, I find that if you go to Python and you can interact with the top level work, And this actually becomes handy when you try to debug stuff, so it's worth talking about it. Just in case you are not familiar, you can use who, you can use PDG. Those are two top-level modules you have access here. And then what you can do, you can use the who load, which is a function passing the path of the load. So in this case, the file pattern node has a full path as tasks, and then topnet1, and then file pattern 1. So that's the load. I'm going to create a variable from this, so you can see that is a top load. Okay, so on this top load, we have a few interesting properties we can play with. The properties like things like n dot, you can get the current selected item. So get selected work item. If I click on this one, you can see it gives you the index of this guy. The index is also shown here, right? So the underscore part, that's the index. And if you do this one, that's a 2, and now it becomes 2. You can find more information about this load by going to the top load documentation. You can see it inherits all the way from upload, load, network item, right? So that's the things you can find. To be honest, there's not too much interesting stuff you can do here if you just take a quick look at this, but that's where you can find the reference. You can find the reference of the who package, of course, on the whole package page. So that's this one. We talk about this. Now PDG package contains some other more interesting stuff. The PDG package gives you direct access to the working item. This is a function, by the way. So it gives you the direct access of the local active work item. So in this case, you can see we are dealing with this specific work item. And this one will give you a whole bunch of very useful stuff. And that will include PDG. Let me just give it a variable name. And then you can see it contains things like attributes, a bunch of stuff dealing with attributes, attribute array, and comment, context. And then you can look at some of the other built-in stuff, like there is inputs and outputs. You can take a look at the item here. There's something called expected input files. Now this one is going to be very important later on, and I'm going to dive in more details. But for now, just be aware those things exist. This one corresponds to input files, okay? And then there's a function called input files for tag, and then we have there's no expect. There's output files, and the output files for tag. So those are the things available on the work item. That's the other thing I want to point out. Now the last thing I want to point out in the Python shell is if you go to any specific load. So here I was selecting the file pattern load, right? Here is a thing called localAttributes, which is a function, and there's something called localVariables, which is also a function. And you can see there are a few names that you may or may not recognize. Actually, I don't recognize anything from here, but for local variables, you can see PDG index, PDG temp, and those things that you may recognize. I just want to point out in case it's handy in the future. So that's everything I want to talk about in the Python side of things. Now let's go through the actual tutorial. If we go to the tutorial page, I'm going to close everything. The tutorial has 3 parts. The tutorial has the first part is to install the the first part to install the prerequisites, right? And then initial setup, and then we are going to convert the images and then bundle the converted images into a new archive. And then from the converted images, we are going to assemble a animation montage. Actually, we are going to assemble the animation montage directly from the original image. And then we are going to assemble the image into a video. In this particular video, I'm going to walk you through these 2 parts. And you are going to see that there is a lot of holes and challenges. And there's a lot of errors in this tutorial. And I'm going to try to point it out. And then I'm not able to do part 3 because there's one particular thing I haven't figured out, which I may make a dedicated video just talk about the issue, but I will point out some of the stuff I have discovered. Hopefully that will give you some insight. All right, so let's get started. The installation part, I'm just going to quickly mention that in case you don't know. So ImageMagick, go to download, find your corresponding platform, and download this guy. It's an installer, and then just double click to install it. For ffmpeg, a little bit tricky, but shouldn't be too complicated. Also, I think Houdini comes with its own ffmpeg nowadays. But anyway, so go to download and find your platform, and then use the this guy. Oh, sorry, yeah. So that's the tricky part. So go here. You can see at the top there's this guy, and then go to the release builds, and then find this guy. Okay, so that is a zip folder. You can just, sorry, this is a 7-zip, a 7z folder. You can just uncompress it and put it somewhere, and make sure add everything to your environment path variable, right? Path variable. So that's the thing. That's the installation part. And then here just showing you that Houdini comes with this 2 archives you can use as the example. Okay, so we have already done that. So here I have set up everything inside my folder. We have those 2, and this thing I'm working on. We can delete everything, but just before we delete everything, let me show you the outputs. So this is the original one. We are going to extract them into the image. Sorry, into the into output folder, which becomes those folders. And then we are going to create the converted results. Where is the converted results here, which are all the PNGs, right? And then, so that's the first tutorial. The second tutorial, creating a montage. Montage looks like this. That's a montage. The third tutorial, haven't done yet, so it doesn't really matter. Okay, good. So now let me just delete everything here and start fresh. The first step is to identify those 2 zip files and go through a uncompress utility. To identify files within a folder, we use a load called file pattern. And then after we have the path to those files, we can go through the uncompress, decompress utility, which will decompress each one. And you are going to specify the input files, output folders, and then it's going to output everything there. And then downstream, we are going to further convert images and generate a montage, right? So that's a general idea. Here, I have everything set up here, and I'm going to give you some overview of this layout. This part doesn't really do anything, just want to make you familiar with my layout so it doesn't seem very distracting. So here I'm just showing the PDG service because I don't need the 3D view and I don't know what else to put here, so I just put in this one here. And here we have the task graph table. You can also summon it from here. It shows you the current running loads. And then we have the log viewer, which is this one. This is very essential actually, because you can run into load arrows, and this one will tell you what are the arrows. And then I'm just showing the load info here as a dedicated panel. So when I click on it, it immediately shows me this, right? So that's the layout. Now, the way we work it, okay, let me just put it somewhere else so it's not distracting. Okay, good. So we have a file pattern. The file pattern node, we are grabbing the pattern. The job is referring to the current file. You can also use heap because the file is saved in the same folder. So we can use a heap, and it's going to grab everything from the from this path that matches this particular pattern. When we run this one, it's going to grab 2 items. If you middle mouse click, I actually don't need to middle mouse click. It shows it here. It gives you 2 outputs in general, and it's also automatically creating those into 2 corresponding work items. Notice here we are splitting the files into separate items. If we don't do this, you can Shift V to run it again. We have a single work item. Now this brings us to the next very, very important concept. I find it very helpful to think of top loads and work items just like SOP geometry points. So you have those geometry points, or just the points, and each point can carry some attribute. So in this particular case, you have actually two different kind of entities. The top node itself, which can carry its own data. Now it may not necessarily be called attribute in this case, but it carries its own data. And you have the work items, which are like the points that carries a whole bunch of attributes. So when you look at the property of this load, you can see the output two files, right? But all of those two files in this case are the attribute of this single item. So this single item include both files in this single item. On the other hand, if you split it and then you run it again, you now have two work items, and each one will contain just one attribute. I mean, they contain the same attribute, but the value of the attribute will contain just one string, right? So that is the way it works. And then to think of those work items, I find it helpful to think of them as individual processes. So essentially, what Houdini is doing, it's allowing you to work on many processes at the same time in a parallel fashion. So here we are grabbing all the zip files. You can decide to either process them in a single process, or you can decide to process them in two separate processes, right? And that will become important downstream because we have a load called work item expand. And before I even do this one, let's run the file decompress first. So the file decompress is going to take the input from the upstream, right? Take the input from the upstream and then use that as input and generate output to some output folder. So let's run this one. In that case, it's going to generate all the output into the output folder. So if we look at the output folder, you can see we have two different decompressed archives. Each one contains corresponding stuff. This one will also find all the files, also output all the files in terms of the file name, and it will aggregate, show all of them, 70 of them on the load level, but on the specific work item level, we have 66 here, and we have 4 here. Now, this is where each work item is a process becomes important. Downstream, when you are processing things, if you have two work items, you can think of them as two processes. So in this particular case, now we need to decide, do we want to process all the 66 images as a single batch, or do we want to process all the 66 images as 66 independent processes, right? If you want to do it as a single batch, then just do it like this. Pass it directly into ImageMagick, and it's going to process it as a single batch. So we have two processes in this case. But you can use a load called work item expand. This one doesn't do something very complex, just expand things one to one. So if we run this one, you can see now we have 70 processes to play with. That will be very important concept because that will directly influence the two challenges with the ImageMagick load. Okay, so the first tutorial, first part is so this is just extracting the things. The first part is to convert images using ImageMagick, which sounds very straightforward, but there are two concept holes in this particular part, and that's why I say this video is a little bit tricky to make. But let's go through them one by one. Let me make sure. Oh my goodness, am I recording? Yes. Okay, thank God. Okay, good. So let's go through the first one. That is, I'm going to show you the correct way it works. So here I'm just outputting everything into a folder. And then for simplicity, I'm just going to use the, I think it's PDG index. Let me find some of stuff I had. So it's the PDG index. Yeah, so PDG index item within the load. And then I am going to do is I'm going to run it directly, okay, and then see what we get. So it's running. And notice that we have only 2 processes, right? Because we have only 2 work items. And then it's going to run. And it's going to output everything to the images folder. And we can indeed get the output PNG files for each of the input files. So that's the first one I'm showing you. I'm going to interrupt this one. We don't need all the images. But notice what happens if we do this one. I'm give it another. And watch what happens if we do something like this. Okay, so now if I run it, we have 70 work items. So we are going to start 70 processes and run through all of them to generate images. Now if we go to the images separate, you can see we get roughly the same thing, right? And did I interrupt it? Why I don't see the other files? Oh, because it detects the file name is conflicting, because the last few ones it's not really working as expected. But anyway, so you can see we have those ones, right? So both of them work, but I want to point out a significant difference in the underlying process. And I actually don't know whether there's a better way to explain this, but I want to point out those seem like it's the same, but it's actually very different. And the reason for that is what I have shown you at the very beginning when we talk about command line usage. If you do open in terminal, let me open the original in terminal. This is too long. Let me just use this one. Okay. So if you open in terminal, and if you use ImageMagick, you can easily convert images, right? That gives you one image. You can also pass in 2 images and convert images. Oh, what is going on here? Image1.png, right? It's still going to convert. And that is the significant difference in this case. In the original example, when we just pass in 2 work items, it's going to try to invoke all of the things as a single command on ImageMagick. That is why we see all of those suffixes. That's why we see all of those suffixes. On the other hand, if you do the other one, if you create 70 work items, it's going to convert them one by one. And that is why we have, 70 distinct images. Okay, so that is the first important concept. So now related to this, I want to show you that how does ImageMagick Node know what are the inputs, right? So for every specific input item, let me just run it again. And I'm going to interrupt that one. For every specific input item, if you middle mouse click or control middle mouse click, you can show all the attributes. You can see a whole bunch of things here. And I'm grouping by type, by the way. So you can see a whole bunch of things here. Those are apparently the internal ones. And the input files, it's a single line of string containing 66 files, and it expands them here. All of this will become the input argument when this single work item is run on the load. So ImageMagick Top Node is essentially a wrapper around the underlying CLI program. And then we have a bunch of other attributes like directory, like file name, extension. Now this is something I want to point out. You might be wondering, why is the file name this instead of frame 00001? Why is the extension zip, right? That is because those attributes are created by the file pattern node. You see, file pattern defines those attributes, and those attributes will carry in each work item all the way downstream. And all the other attributes are created by the ImageMagick node itself, as we were showing here, right? So batch mode, that is an attribute created by ImageMagick node. So now you can have I think by this point you have a much better understanding of how this whole thing works. So each node is kind of like a wrapper around some kind of processing tool. And then it's able to invoke that tool, passing the inputs and outputs, and generate a bunch of results. In the process, it's also populating some attributes onto those work items. And downstream, all the work items will keep carrying those attributes until they are either deleted or new attributes are created, right? And then other nodes are just making use of those attributes either explicitly, you can do it like this, explicitly making use of some attribute, or implicitly making use of the input files, output files, those kind of stuff. Okay, so that is how it works. I think if you can understand this, then you can immediately understand the second tricky part of this tutorial, which is what this guy is saying. The input file name attribute seems gone. Then how can we set the file name, right? So previously, according to the tutorial, it's asking you to directly do this. And then let me find the exact thing. It's asking you to do something like this. Okay? So it's going to ask you to put this one as here. That's the output file path. And then it's trying to somehow using this magical input file name that will correctly identify each output file, like image 1, image 2, image 3, and then expect to run, which if you run it, it will not work because that attribute does not exist. Actually, in fact, I'm not even sure whether this is the correct syntax to use the attributes. But anyway, you guys' idea, and you can see it doesn't work, and it gives you this suffix, which is generated as a process of ImageMagick itself, because it's trying to convert multiple images into the same file name, right? And then, let me interrupt this one. You can use something else. So you can see that we actually created a whole bunch of, we actually have a whole bunch of things like the file name. So in that case, if you do something like file name, then it should work. You see, yeah, that is the thing. I don't believe this is actually a legit syntax at all. Maybe it's not a legit syntax. Let me see. If we do something like this, and let me run it again. Oops. Shift V. You see, this is not even a legit syntax. I don't believe that's a legit syntax to reference to the attributes. But the one thing that does work, as someone pointed out, you can use this way to refer to the thing. Yeah, leave a comment if you know whether that curly braces does anything. And if you do this one, that will work. But this file name is not the file name of the decompressed images. It is a file name created during the file pattern process, which is those things, right? So now, if you take a look at it, where did it go? Images, I think I should see, yeah, see, they are generated here. Okay, but again, those file names, they contain those suffixes because of the process of converting multiple images into the same output image. All right, so that explains that. So to correctly convert the images, what you would want to do is to probably do this, or you can do some fancy other stuff, to somehow get the correct file name from this thing, or alternatively you can just do something like that, and that will give you something a little bit nicer to play with. Okay, so that's the first part. I'm going to go back to this one and explore a little bit how we can actually implement the file name at the end of this video, after I talk about the other stuff. Now for the montage, we essentially do the same thing. We just grab the thing and go through the montage here. Now this one makes more sense to only have two processes, right? So each work item represents one process, and each work item we are trying to generate one output, which is the PNG output. In that case, it makes a lot of sense to process all the 66 items in a single batch. So we don't need to expand it. Now montage, if we run this one, is going to generate the montage as I shown at the beginning of the video, right? So that is the montage one. Okay, so that's pretty much it. I think with all the stuff I've talked about, you should have a pretty good understanding of how top works, and even if things don't work, you have a way to dig into it, understand what is going wrong, and etc, etc. So you can close the video now, but I'm going to talk about something else. So far I have shown you part 1 and part 2 of the tutorial, right? The part 3 of the tutorial is trying to generate the movie from the image sequence by using ffmpeg. Now, the first problem you will hit. Now, I mean, for the ffmpeg encoding, that one probably trivial, right? Just give it a bunch of images, it should work. I have never tried it, it should work. But the tricky part is a filter by expression node. This is a very smart way to do stuff, but it just doesn't work. So I'm just going to delete this thing. And what I'm going to do, I'm going to do something like this. Filter by expression. So notice here we have two work items. Each work item contains 66 versus 4 output files. And what we are trying to do here, let me just delete this one, filter by expression. What we are trying to do here is to remove one of the item, because for the video we're going to generate, the 4 image item is too little image, so we want to only deal with the 66 image item. So to do that, we are going to use the filter by expression. The way this one works, if it is 1, then we filter it out, essentially remove it. If it's 0, we don't filter it out. So if we just run it, you see 0, everything is kept, all the attributes intact, nothing is changed, exactly the same. I mean, actually it looks like it's not exactly the same, something is gone. So we have like 7 attributes in this case, and we have 10 attributes in this case, but you know, doesn't really matter for our purpose. Okay, good. If it's 1, then we remove it. So if we run it again, you see both items are removed. And the tutorial is trying to filter it in a smart way by writing a Python expression. So the logic here is that, you know, we know each item has about how many? 66 output files, right? So what we are going to do is to filter by the number of output files using a Python expression. To do that, go here, use Control-E, and change this one to Python, and then we can paste in Python expression. If you apply, accept, try to run it, nothing happens. Absolutely nothing happens. And the reason for that is none of this, I mean, part of it makes sense, but most of it totally doesn't make sense and is not going to produce anything. Now here I'm going to show you 2 tricks. The first one, I mean, I'm going to show you 2 tricks to debug this one, okay? But before I show you the 2 tricks, the correct way to get this one is actually to do input files for tag. Actually, I don't quite remember. Is this the correct one? No, this is not the correct one. All right, so if we go to the work item, and where is the input files for tag? Okay, I don't even remember what's the correct one. So let's just figure out together. So to debug this one, the way we can do it, open your Python shell. Open your Python shell, okay? And then if you connect on anything, now you have this work item, right? You have this work item. So what you can do here, you can inspect what is available and what is not available. So previously, according to the tutorial, it's trying to use output files for tag. So let's just take a look at whether that thing exists. So if we just paste it here, you can see we do have output files for tag. Right? That is very wondrous. So we do have output files for tag, but actually what we should do is not look at this work item. What we should do is, I'm just going to delete this guy. Go to expression. I think there's a way to delete this thing. Delete channel. Okay, and then don't filter anything, and then run this. So we should select this one to actually inspect the state when this work item was running. So if we just do this one, you can see, okay, we do seem to have something. Then why don't we, why doesn't it work, right? You can do a len bigger than 10, false, but if we select the first one, bigger than 10, it's a true. So why doesn't it work, right? So the way to debug this is if you keep this open, and I'm going to edit the expression again. So instead, this time, I'm going to do this, but instead of just apply it, what I'm going to do, I'm going to print it. Okay, I'm going to print this guy, apply this guy, and you can see, okay, it looks like it's actually working, right? But if you cook this one, you can see it's empty. Why is that the case? This thing is empty, right? When you cook this work item, it's empty. That's why it doesn't return anything. That's why when you do a bigger than 10, it's always false because it's empty. So what we are going to do is, if you remove all the way here and apply, and it looks like it's lump, but actually it's not lump. If you run this one, it seems okay. We do have a work item to play with. Right? We do have a work item to play with. That part is true. But this whole thing, output files for tag, is empty. But what about, do we have any output files at this moment, right? If you think clearly, when this work item is created, when it is running, there's no output files yet. So output files for tag will not give you anything. That is why instead of output files for tag, what you should actually be using is input files for tag. Okay, but even before we go here, just want to make sure we have input files. So there are two variables that concerns input files. One is called input files. The other is expected input files, which actually produce the same result. But let me just show you. Apply, run this one. You see we do have some input files. Okay, we do have some input files. And it's like this. And you do expected input files, apply. You can see it's the same. But here is the very interesting thing. The input file is pointing to the zip, which is very, very weird. Because after the file decompress, you would expect the output file to be those ones. The input file should be those ones, right? Right? So if you look at this one, the input file originally was a zip, but output file should not be a zip. It's the JPEG file. But here, it's showing you the input file is indeed the JPEG, and the output file is indeed JPEG again, but when you run this expression, it is not JPEG. So what is going on here? So what is going on here? Actually, okay, at this particular moment, I am kind of forgetting what is going on. Oh, okay, I think I remember what is going on. Yes, that is exactly why I haven't figured out how to do part 3 yet. I don't know what is going on here, but it's certainly not working as expected, because it should be, and I'm going to prove it to you. Because if I click on this guy, and I do this one, right? I do expected input files. You see, that is the expected input files, and I can do something like input file by tag, file image, right? Probably input files by tag. What's that called? Input files for tag. Sorry. Right? See, we should be able to have some input files. Okay, good. So that's it. So that's why I haven't figured out how to do part 3 yet. But I have shown you how you can debug it, how you can play with it, how you can print it to find more information you want. Now we are done with this part. There's something else I want to talk about, and that can help us consolidate our understanding of the whole attribute thing. So here we have this thing. Right, here we have the drag it over. Okay, good. So we are going to expand the work items. Right, we expand the work items. Now here is something we can do that is very fun. We can partition by attribute by specifying the file name. Now the file name actually refers to the original zip file name. Okay, so I'm going to change it all the way here. It's not called file name. I can do archive, original archive name. Right? So I'm going to cook it, and cook it. And now you see we have the original archive name. And then we can partition those 70 processes by a single attribute and group them together to go back to the original 2 work items. And then we can do a file compress, which takes whatever is given us and then output, a result output with the index of the either 0 or 1, the corresponding zip file, and we run it, and then we will be able to get the result, the 2 archives. Okay, so I just want to show you this example so we know how the expand and partition works, and then how everything flows nicely. That's it. Thank you for watching.